So how'd you do with these? Good? Did you get number one? Well, then if you're confident, fast forward to number two. But in the meantime, those of you who want to see number one, let's do this. Tell me what you did. Like, oh yeah, that's a complex fraction. I agree. So, good, you took it in pieces. So what'd you look at first? You looked at the numerator. And so in the numerator, we are technically doing what? We are adding a couple of fractions. And I agree with you on that. So to add fractions, common denominator, what would that be? X squared. So I guess fraction number one needs to get multiplied by an x, top and bottom. How about fraction two? No, fraction two is okay. It already has an x squared as its denominator. So tell me what we get in the numerator. 2x plus 3 over x squared. Excellent. So now what? You looked at the denominator. And in the denominator, we are subtracting a couple of fractions, aren't we? Good enough. But regardless, yeah, you need a common denominator. So, x squared, got it. Tell me then, so we end up with x minus 1 over x squared. Excellent. So I know what the numerator looks like. I know what the denominator looks like. Okay, let's go back to the original problem. So this is my numerator, but this is what it simplified to when I added the two fractions. What does that line mean again, separating numerator and denominator? Division. So the numerator is being divided by the denominator, and we did that work over here. This is what it looked like when we subtracted them. Ah, good. We get to multiply. And reciprocate fraction number 2. Good job, you guys. So 2x plus 3 over x squared. You're multiplying by x squared over x minus 1. Lovely. What happens? The x squareds drop out. Does it always happen? No. But when it does, hey, I take it. I take it. Okay. Can I cancel anything else? Good, you cannot, because addition and subtraction won't let me pull things apart. It has to be multiplication. Good with this one? All right, problem number 2 coming your way. Okay, how'd you do with problem 2? Good? Walk me through it. Tell me what you did. You looked at the numerator first, okay? So what are we doing in the numerator? We're subtracting a couple of fractions. Understood. So tell me then what you had to make certain of. You had to make certain you had a common denominator. What is my common denominator in this case? 4a. So fraction number 1 has to get multiplied by a 4 on the top and bottom. Got it. And then we end up with 28 minus 3 over 4a. Oh, well, I can do 28 minus 3, can't I? So 25 over 4a. Perfect. Lovely. Didn't expect that one, but hey, works for me. Denominator. So in the denominator, what are we doing? We are adding a couple of fractions. So we have 4 over a plus 1 over 4a. What do you got to do? Common denominator, so multiply the first one by 4, top and bottom. Got it. Which 16 plus 1 over 4a? Well, this problem is working out really nicely, isn't it? I'm liking this. How about you? Yeah, sometimes we get these gift problems, shall I say, because they're not as bad as they seemed. Okay, so the numerator, 25 over 4a, good, divided by the denominator, which was 17 over 4a. Make it a multiplication problem. Tell me what you wrote. 25 over 4a times 4a over 17. You're like the 4a's drop. I got 25 over 17. I can't reduce it. You're right, you can't. Final answer. Good? Lovely. Got another one coming your way, so stay tuned. Okay, how'd you do with this third one? Yeah, this one was a little more involved, wasn't it? But you know what? The concept's still the same, right? Because if I look in the numerator, I'm simply subtracting fractions. And in the denominator, well, I've got addition and subtraction of fractions. So is it really all that different? Good. I'm glad to hear you say no. So what'd you do first? Looked at the numerator. So we have 2 over 1. Yes, I'm going to make it a fraction, right? Or I'm going to write it like a fraction so I can see it nicer. Okay, you're subtracting these. What do you need? Common denominator, x squared. So the first fraction, you multiplied by x squared in the numerator and denominator. Fraction 2, multiplied by x, numerator and denominator. Fraction 3, didn't have to do anything. Got it. So let's see. It looks like we end up with 2x squared minus 3x minus 2 all over x squared. All right. By the way, as you can tell, once I know I have the same denominator, I like to just write it as one big fraction immediately. It saves me a step of work, but really it gets me to understand that I can write it as one fraction since I've made the denominators the same. Okay, so let's look at the denominator. We have 1 over 1, make it a fraction, write it as a fraction, minus 5 over x plus 6 over x to the second power. Got it. What are you going to do? Common denominator, x squared. So the first fraction, multiply the numerator and denominator by x squared. Fraction 2, multiply the numerator and denominator by x. Fraction 3, good, nothing. Because it's already the correct denominator. So what'd you get? We have x squared minus 5x plus 6 all over x to the power of 2. Okay, now we have the numerator and denominators figured out. What'd you do? Rewrote. So the numerator, which is 2x squared minus 3x minus 2 all over x squared, good, divided by the denominator, which is x squared minus 5x plus 6 all over x squared. Reciprocate, I hear you. And yes, we all know by now, fraction number 2 is the one that reciprocates. And so looky there. Can you tell what's going to happen right away? Yeah, these x squareds drop out, don't they? Yay! So I have 2x squared minus 3x minus 2 all over x squared minus 5x plus 6. Okay, finished? Some of you are saying yes, some of you are saying no. Some of you are like, I want to be done. I get it. But remember, when it comes to polynomials in a fraction, what do you sometimes have to do to see if something else will cancel? Ah, yes, you have to factor. Why do you have to factor? What operation does factoring give you? It gives you multiplication. So, if you haven't factored these, pause the video and go factor them. And if you're like, oh my gosh, I need a refresher on factoring, go find my factoring video of trinomials. But in the meantime, ready? Okay. So let's see. This is what I am getting. 2x squared minus 4 plus 1, good. And in the denominator, looks like it's good. With me? Do you see it? This is why we had to factor, because the x minus 2's will drop out, and I'm left with 2x plus 1 over x minus 3. That's as simplified as I can make this particular complex fraction. Good? Okay. If you need to rewind, watch any of these problems again. Some of you may want to watch this last problem again. Have fun with it, and I'll catch you on the flip side.